Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're going to be discussing section 4.5. It's a factoring trinomial section, and I have leading coefficients this time. So I'm going to share with you what I believe is the most effective way to factor. There's many techniques of factoring, and I'll mention a couple of them in this video, but I found through the many years that I've been teaching that the method I'm going to be teaching is going to increase your chances of being successful for factoring. First of all, you need to watch the video from section 4.4 where I explain about what the signs mean. So here I need factors of leading coefficients are 1 in section 4.4. So this says signs are going to be alike. They're both addition. So I've added the signs. This says signs are going to be alike. They're both minuses. This says signs are going to be different. One's a plus, one's a minus, and this tells me what the larger is, so I put an L. So again, factors of 6 that add up to 5, because this is a plus sign. Factors of 6 that add up to 5, well, factors of 6 are 1 and 6, 2 and 3. So I'm going to pick the 2 and the 3. And signs are alike, they're both same thing here. Factors of 6 that still add to 5, even though this is a minus sign. I'm still going to pick factors of 6. And it doesn't matter if you put this the 3 and this the 2. The order that you multiply these in does not matter because 5 times 4 is the same thing as 4 times 5. A little bit more difficult when signs are different though, because then I've got 1 plus and 1 minus. So here, factors of 6 that differ by 5. So instead of using the 2 and the 3, use the 6 and the 1. And this says make sure that the larger one is positive. So this is the 6, forcing this to be the 1. You can check these by doing the FOIL method. Here signs are different. The larger term is negative, so make sure that the 6 comes over here with the negative this time. So again, you want to review section 4.4, those rules, before we move on for today's lesson, because I'm going to teach this lesson, section 4.5, the same way. I'm just going to have a leading coefficient this time. So here we go. I need to find factors of 2 and 6 this time that still add up to the middle term, which is 7. Don't worry about positive 7 or negative 7. The rules state that I can pick any number over on the left side to go to any number on the right. So I can put the 2 with the 2, I can put the 2 with the 3, the 2 with the 1, or the 2 with the 6. But I need to make sure that whatever I throw together, that I'm going to have factors of 2 and 6 that add up to the middle term, which is 7. So looking here, if I choose to put the 2 with the 2, that's 4. And I cannot put the 1 with the 1 or the 1 with the 6 now. I've got to put 2's buddy, which is 1, with this 2's buddy, which is 3. Unfortunately, its product is 3, and that adds, well, that does it. That added up to 7, so I got lucky. So these are my first terms if you know the FOIL method. Those loops stand for the outer and the inner, and then the last terms are either 1 and 6, 2 and 3, and it looks like I'm going to be using the 2 and the 3. So I'm going to use the FOIL method. The first terms have got to be 1x and 2x because that's what I've highlighted here, 1 and 2. So I stick those as my first terms. Here comes what I would consider the most important thing. After first terms comes outer terms. So please draw that line because it represents outer terms. And then I just follow the red brick road. The outer terms in this case are 1 and something. Well, look over here, 1 and 3. So I just put the 3 in this spot, forcing the 2 to go to another 2. Signs are alike, they're both positive, and I'm done. Of course, I'd want to check that answer. Here's how the book says, just trial and error, just keep trying things, but that is the correct answer. So again, there's lots of methods. Here's how the book recommends. You can pause the video and read through all of this, but I kind of like the method that I'm teaching you. It goes along with section 4.4 and 4.5. Let's keep going. Look for the greatest common factor first. I can't divide everything through by 2, and I've got m's and n's, and I don't have any common factors. So I'm just going to list the factors of 18, list the factors of 12. There's a lot of them. 1 and 18, 2 and 9. Let's go systematic. 1, 2, 3, 6. 4 doesn't go in there. 5 doesn't go in there. And as soon as you hit a number over here, we're done. Let's try it again. 1 and 12, 2 and 6, 3 and 4. And I've hit a number on this side, and again, I'm done. So I'm looking for factors of 18 and 12 that differ by 19. So I know I need some big numbers. So here comes the hunt. Remember, any number over here in the first term slot can go to any number in the last term. So if I just randomly choose something like 9 going with the 2, which is 18, I'm going to force the 2 and the 6 together, which is 12. But that doesn't differ by 19. 18 and 12 have a difference of 6. So I'm going to try something else, and you'll get better at this as you keep searching. I'm trying to undo these lines so you can use your eraser. So again, it's just kind of guessing and checking, but you can kind of visually see this pretty quickly. 6 times the 3 is only 18, and I need things to differ by 19, so I'm probably not going to stick the 6 and the 3 together. I need big numbers. Oh, like 24, that's better, but then 24 and 9 doesn't differ by 19, but I'm getting closer. So let's go bigger. Even larger is 9 times 3, which is 27. And again, you cannot put the 3 or 6 with anybody now. You've got to use this 2 because it's the buddy for 9. And you've got to use this 4, which is the buddy for the 3. And yay, look at this. 2 times 4 is 8. And 27 minus 8, sure enough, is 19. So let's go plug these in. My first terms are right here. I've already identified them. I'm going to use the 2 and the 9. So I'll plug those in for right here. 2x and 9x. Or actually, it's not an x this time. It looks like it's 2m, trying to get this term, and 9m. But don't get overzealous and head toward that last term yet. That's the mistake that students usually make. Don't worry about that 3 and 4 yet. Instead, I would follow this green brick road. 2 goes with a who? And it looks like a 4. So I would draw that line, the outer brick road. So after first terms comes outer terms. So here comes the outer terms, 2 and who? And it's right there, 4. So I'm going to stick a 4 here. Let me try that again. Stick a 4 here. And then the 9, the inner terms, looks like it better go with the 3. Signs are different. The larger term, not the larger number. This is the larger term. Let's see, 9 times 3 is that 27. So make sure that that 27 is negative by putting a minus there and a plus sign right here. All right, we just need to try a couple more of these. And it looks like the author got the same thing, 9m plus 4. It doesn't matter if you do 4 times 5 or 5 times 4. The order that you list these parentheses in does not matter, but the author did it backwards, but it's still the same answer. The AC method, again, is another method, but I'm just going to introduce it in case someone mentions something to you. Yes, we could factor by grouping. There's all sorts of techniques, but I really like the technique that we're doing right here. So let's continue with this. No GCF. I need to find factors of 4 and 15, and this time that add up to 16. So there's not that many terms. So here we go. I call this the Great Hunt. You're looking for any factors of 4 and 15 that add up to 16. So, I'll just try something here. 2 times 5 is 10, and I'm going to force this 2 with the 3 because I've got to put the buddies together, and fortunately for me, 6 and 10 adds up. So I got lucky again. Sometimes we don't get lucky the first time, so we just keep trying. So 2x and 2x are my first terms. Don't plug in those last terms. Remember, you've got to draw this line. That's what saves people, is drawing that. I'll make it a blue line this time. So the blue, well, it doesn't matter. The 2 goes with the 3. Here you can't go wrong, really, because 2 goes with the 3, and then this 2 goes with the 5, and it doesn't matter that the order you do that. Make sure signs are alike. Oh, I got lucky. They're both positive. That was an easy one. So here's how the book chose to do it. Again, it's a little bit more complicated. If you ask me, you're welcome to read through the book and see how they're doing this by factor, by grouping. I think it's absolutely ridiculous. I like my method, which is kind of a trial and error method. We're just looking for all the factors of the first and the last, and we're just trying to get those outer and inner terms, and that's what these loops are, outer and inner terms. So I'm just going to keep showing you this method. If you would like to try a different method, you could. But again, I found that students are most successful with this. So here it goes, factors of the first and the last, this time that differ by 5. So 1 and 6, 2 and 3, 1 and 6, 2 and 3, and we need to differ by 5. So this is the hardest part of it. I got to find factors that go together that differ by 5, and sometimes that's difficult to do. And by the way, if I can't find any factors, then I will just say it's prime. But before I dive into this too much, I do see that I've got a greatest common factor. So let me back up here, because see, this is x to the 4th. So I should have been able to factor out an x squared first, giving me 6x squared. That'll help me a little bit, because then I could just go something x, and I don't have to worry about getting that x to the 4th, although I could deal with that, but I don't want to mess with it. So let's pull out an x squared first. So if I divide each term by x squared, here's what's, don't throw this x squared term away. So minus 6. So I'm still looking for factors of 6 and 6 that differ by 5, though. I'm going to stick the 2 with the 2, because 2 times 2 is 4. 3 times 3 is 9, and that differs by 5. So my first terms are 2x and 3x. Again, I'd like to look at this yellow brick road. A 2 goes with a 2. A 2 cannot go with a 3. So I've got to put this 2 with a 2 over here, forcing this 3's together. So my outer terms are right here, which are 4x. My inner terms are 9x. And it says signs are different. The larger term is positive, so I've got to make that 9x positive, forcing this to be negative. And the only way to get that 9x positive is to stick a plus sign here. This says signs are different, so it's a minus. I'll show you a couple more examples. Again, here's how the author did it. Looks like we got a good answer. So a couple more examples. I always look for a greatest common factor first, and this looks like, oh my gosh, maybe everything divides through by 3. You could try that in your calculator, and it looks like I have an x to the 4th. So I'm going to divide each term by 3x to the 4th, so I can just have smaller numbers to work with, which in turn creates less factors. So always look for the greatest common factor first. So 18 divided by 3 is 6x squared minus 19x plus 10. So this time, instead of listing factors of 18, now all I have is factors of 6. A little bit more manageable. And factors of 10, 1 and 10, 2 and 5. So here I go. Always factor completely. So you may think I'm done after the GCF, but I'm not. Let's see if we can find factors of 6 and 10 that add to 19. So I need some big numbers. So I'm going to try, maybe 3 and 5 is 15, forcing 2 and 2 together, which is 4. And I found it. That adds up to 19. So my first terms are 2 and 3. Don't use the 1 and 6. So you can go 2x and 3x, or you could go 3x and 2x. It doesn't matter at that point. But once you've committed, then here we go. 2 goes with a 2. Those have got to be my outer terms. So I'll stick a 2 with a 2, and the 3 has got to go with that 5. So notice, the outer terms is 4x, the inner terms is 15x. That's what adds up. So signs are going to be alike. They're both negative, and I'm done. Again, here's how the author went about doing this. Last example, and then you can try some here. Factors of, well, let's see, any GCF? No. So 30 and 11. 1 and 30. 2 and 10. You should probably pause the video and see if you could do this yourself. Not 2 and 10. How about 2 and 15? Boy, there goes my talking and writing at the same time. Oh, great. Okay, maybe I should use an eraser here. So sorry about this. 2 and 15. 3 and 10. 4 goes in there. How many times? No, 4 goes into 28. 5 goes 6 times, and I hit a number on this side. Over here, easy. Only 1 and 11 works. So here we go. Factors of 30 and 11 that differ by the middle term, 23. Okay, so I know I'm not going to stick the 6 and 11 because that's 66. But I do need a big number because 23 is... Okay, here we go. 3 and 11 is 33, forcing 10 and 1 together, which is 10, and that differs by 23. Again, it was just trial and error, and you'll get better at that. So here we go. My first terms have got to be 3 and 10. I'm going to use m's this time to get the m squared. 3m and 10m. I'm going to draw this outer brick road. The 3 goes to a who? Well, look over here. 3 goes to an 11. 10 goes to a 1. Signs are going to be different. The larger term is positive, so who's larger? Well, this 33 is larger, and that forces this to be negative. Great. Looks like the author got the same thing. Now be careful on this larger term business. Sometimes that's tricky. If you don't read these signs correctly, you might get confused and think it's the larger number. So if you list the factors here, these are an easier one. So, but be careful. There's a trick in here. If I say 1x and 3x for my first terms, look at this. The outer terms are 1 and, well, let's see, differ by 2. Maybe I should do this part over here first. There it is, 6 and 4. So the 1 has got to go with who? Well, it looks like the 1 goes with the 4. Now here comes the trick. if you put a 4 here, the 3 goes with 2. If you think this says factors of 3 and 8 that differ by 2, you're correct. Signs are different. You don't say the larger number is positive. It's the larger term, because if you chose the largest number, 4 is the largest number here. So you might think that a plus sign goes right here. But actually that's going to be wrong, because then your outer terms, which is 4x, is not larger than 6x. So that's why you can't say the larger number. You've got to stick with the larger term. So the larger term is 6x, which forces the positive sign to go here. That's because you need a plus sign here and a minus sign here in order to get a positive 2x. I hope that makes sense. Last example, you might have to rearrange these before you factor. So let's put them in descending order. And then as soon as I put them in descending order, I think I see a GCF of 2. So let's try 3r squared minus 14r minus 5 if you factor out of 2. So listing factors of 3 and 5. So the trick here was put it in descending order and do the GCF. Factors of 3 and 5 that differ by 14, so I got to use 15 and 1. The first terms have got to be the only thing I have, 1r and 3r. And in this case, the 1 goes to 1. So here's the outer terms. Don't do the last terms. After the first terms come the outer terms. Now the outer terms are right here, 1 and 1. I've got to go outer. And then that forces the inner terms, 3, to go with that 5. So there it is, 3 and the 5. Signs are different. The larger term is negative. So the larger term is obviously here 15. Make that negative, make that positive. I hope that video was helpful. Email me with your questions.